Yeah, I'm Shaji, and I do product management for IPI. So what we have here is OcNOS. So I'll get into a little bit of detail into some of you may have questions where we get that modularity from. So we'll basically touch upon that. Primarily our expertise is basically spans the gamut across multiple network elements. So be it switches, routers, or application delivery controllers, or any network element you can think of, we have a play there, partly because we are deployed there today, and essentially we have products in every category. So I can provide you offline references of the full list of products, but to give you a sample in the core aggregation and access side, if you look at NEC's PASO-Link series, right, it essentially uses basically our control plane as well as data plane integration. And Foundry, if you look at our 7.3 software, used to be in the big iron. So if you look at the BGP, OSPF, ISIS there, and likewise in Extreme, basically you may not know about us, but because vendors typically brand as their own OS, and it doesn't come out as Zeb OS. But in some cases, like in F5, you may be able to see it actually points out to our protocol by it'll call it out as our control plane basically. So in some cases you may see it, in other cases it's hidden behind the scenes. So this is just a list of products that span all the way from edge, core, aggregation, transport. Yep, sure.
So looking at other vendors out there, you may buy a switch that's layer 2 only.
Yep.
You buy another one that's layer 3 only.
Yep.
Now, how does that work with your OS? If it's a white box and it's on a piece of hardware,
yep,
is every piece of hardware capable of the same things, or is there any kind of variation?
So, I'll come to that.
Okay.
So
thank you.
That's exactly the next slide. So basically, OcNOS, like as Tetsuya mentioned, it has 3 components, right? To build any network element, you need 3 components. Basically, the data plane integration, the control plane, and the management plane, right? And high availability middleware, and then the middleware to manage the actual hardware. So essentially, if you look at this, so we begin from the bottom up, right? So you have this base hardware here. On top of that, you would have some kind of operating system. So we abstracted even those pieces because our software can run even on VxWorks or Windows or anything. What we have here is a PAL. A PAL is a platform abstraction layer. It basically takes out the OS constructs, everything that the OS gives and abstracts it out. So essentially what that does is it makes this module here, which is basically the interface manager. So this interface manager is the one that is giving you the access as it transforms your physical entity into a logical entity, basically. So that's where the abstraction comes in. So the protocols that are running on top of it, they have no visibility into the underlying hardware. I'll peel each layer of the the control data as well as management plane and explain how those things fit in. So this is the organization for the OcNOS basically, and on top of that we have a model-driven architecture basically, right? So essentially these are the 3 key components. Now let's take them one by one. So the control plane, right? So the control plane, basically if you look at the control plane, what it does is you have this NSM, which is the key module, which is the service module. This service module, what it does is it does the interface management, and it does things like basic things like things that need very specialized functions like ring protection, for instance, linear protection. Those kinds of things basically get implemented here. And you have a RIB daemon, which basically keeps track of all the routes that are learned from the protocol modules, basically, right? So OSPF RIB, BGP RIB, all those things are kept here, basically. Then what happens is you have to interface with the TCP/IP stack, basically. So you call the PAL and you program the fib that sits basically in the Linux kernel, right? Then there is something that sits very close to the hardware, because this is where it doesn't have everything that the RIB has. It basically has forwarding information, basically. So that's how this is organized, right? So the service layer, now depending upon how good this hardware vendor is in terms of giving you SDK, if it's an NPU and it's a task-oriented processor, then you may not have an SDK. So in those cases, we write our own forwarding plane, basically, making use of the underlying infrastructure, right? So essentially, depending upon the capability of the underlying hardware, right? Depending upon the data path pipeline, you may have some functionality. Like let's take the case of Trident plus Tomahawk. In Tomahawk, it's a spine switch, so it may not have traffic engineering functions, right? It may not be able to do things like IRB, for instance. So in those cases, we'll have to trick the hardware as to making it into two parallel pipelines. You take it out of the one pass and then bring it back in, or augment it with external hardware, basically, right? But if it's something like a fully programmable switch, like let's take the case of Barefoot, where it's a sequence of ALUs, there you can pretty much program the pipeline completely, or it could be an FPGA, for instance, right? But this thing remains the same because it's completely abstracted out, right? It has no dependency on the underlying hardware. The functionality that you get on a particular box basically depends on the underlying hardware's capability, right?
So, so it's not going to be the identical list. It'll be close,
but
I mean, yeah,
close
they're
enough.
still hardware dependent a little bit.
Like for instance, as I said, right, Trill, if you take Trill, that implementation may be very specific to Broadcom.
Okay.
Right? But it may be a little bit different, like if you were to do on your own, basically, right? So you'll see those differences, like even when we talk about OcNOS, because in OcNOS, we build out the data plane completely. So it's a virtual product, so we are free to, anytime, what happens in this industry is the standards come in before the hardware. So we have to actually code it immediately, right? So we have to have a basis to test it. So we will model that hardware in software, basically. Have a forwarding plane to test out all the capabilities, right? And the hardware follows later. And it may have like 2 or 3 iterations, basically, before it gets there. Like if you take Trident through Trident 3+, the Trident 3+ is fully programmable. Whereas if you take Trident, when the Trident first started, it didn't have all the bells and whistles that you see today, basically, right? So it's more often than not, when a specification comes in, even if it's in a draft stage, we'll implement it. And we'll have some data plane piece that will be in software, essentially. So to answer your question, yes, depending on the underlying hardware, you get those capabilities.
So from a presentation layer, if I'm consuming this abstracted control plane, and for the most part, from a Trident to a Barefoot to Broadcom, I'm going to get that consistent interface because I've abstracted it.
Yep.
So from a troubleshooting perspective, because not all 3 of those are equal in capability or focus, what data am I getting back to understand what is a limitation of the abstraction layer versus the underlying hardware?
Yeah, so what we do is we basically, in addition to what we have here, what we have is a platform. Basically, think of it very similar to a BMC controller, if you're familiar with the BMC piece, right? So what it does is it captures all the underlying hardware states also. So it depends on how good your vendor's hookup is. Like if you basically get those statistics, we can read those values. Like we can basically write a small daemon which basically reads all the register values and presents you that information, basically.
So you can present that telemetry data from the chipset itself, from the chip to whatever tool I have. So if I have the talent to understand that telemetry data, I can understand where my potential bottleneck or issues are at.
Exactly. So what will happen is, like in certain chipsets, right? If you look at something like a Tomahawk versus or a straight DNX chip, right? Like Qumran, right? The traffic engineering would be different, right? Because it's meant for edge aggregation. So in edge aggregation, there's a lot of grooming that happens. So if you look at that versus a spine switch, right? It'll be completely different. So the statistics that you get would be dependent on what the underlying layer is. Even though you get a normalized interface, we would call out when you do a show controller equivalent like in Cisco, right? So you would we'll basically give you that information. We'll say hardware is this, and this is the register values, this is the capability. Right. Okay. So this is from a control plane standpoint. So the RibD basically is a pure daemon which keeps the routing information, essentially. And likewise in MPLS, currently we have the FTN and ILM entries, but we are working to remove that, to decongest this layer so that it's a pure interface manager. Why? Because we see that as the speeds increase, like in 400 gigabits, Ethernet is round the corner. So as it comes in, there will be multiple virtual interfaces. So we don't want this to be a bottleneck. So we're cleaning this out completely. So this will be even super scalable, basically. And the beauty of this architecture is it can run on any modern processor. It can leverage this because it uses standard Unix domain sockets. So essentially, you can split it across process level, or you can basically run parts of the protocol spread across. Something could be running very close to the hardware. Like for instance, if you take BFD, things that need to run very close to the hardware, that will sit right next to a coprocessor or an inline function within the chipset itself. And the rest of the control plane pieces could run in your CPU. So essentially, it gives you that scalability. So that's why we have and this architecture didn't evolve overnight, right? Because we were dealing with multiple different vendors, and each vendor had their own piece of hardware. So that's where the DNA is, basically.
So from a stability perspective, so obviously if I can scale this up, if I can take a barefoot to Fino and scale this up to be a massively scaled box on the top end, you guys will handle that well. Have you guys started to get use cases where I scale this out into a distributed switch, not necessarily just virtual, but physically, where I'm taking these components and
yes,
stretching them out past?
Yes, we have seen some designs where what they've done is like they have the data plane completely separated out, and in between, this is specifically, we saw a recent use case where it was for HPC, where they were trying to replace InfiniBand with Ethernet, basically 100 gigabit Ethernet. So essentially, the backplane was completely hardware switches, and the control plane was actually running on top of a controller. And that was basically programming all the FIB tables, basically, right? So that's a distributed case where the hardware itself is running a very lightweight control plane, and the heavyweight control plane is basically still interfacing with your external entities, right? So it's a seamless transition. So it can work with interwork very seamlessly. Right? So this is basically the control plane piece. So I want to touch upon the. This is where it basically becomes very interesting because we can work across chipsets very quickly. Typically, you'd have the vendor device and the SDK here, right? And sometimes you may not have the SDK. You may just have processors, task-oriented processors. So in that case, what we do is we actually, you want to logically look at this as abstraction layer and a service layer. That service layer basically deals with all the idiosyncrasies for a particular chipset, right? So we hide everything right here, very close to the hardware. So essentially what happens is, whatever you get, the model that you get here is a logical model of a chipset, of a forwarding plane. In some cases, it would be, it'll have a lot of bells and whistles, and in some cases, it's not programmable because it's a fixed pipeline switch, right? So this is what actually gives that capability. And we can very easily port over from one silicon to the other very quickly because we do that today. It's just that there aren't any white boxes with alternate chipsets because Broadcom being the most prevalent right now.
Yeah, that's why, well, that's a question I wanted to ask. If a customer is going for the white box solution number one,
yep.
If he wants to migrate to the white box solution number two, what would be the effort that they have to provide in order to switch everything?
So essentially, from the operational standpoint, they don't see any difference, right? They won't see any kind of difference. It will basically, let's say they got another white box,
yeah,
and it's a Marvel one. Let's say it's a Bobcat-based Marvel, and you take this one, right? This is, let's say, assume this is based on Trident 2.
okay.
So if you were to compare both, from an operational perspective, they won't see any difference. The only minor differences would be, like things that get implemented in hardware in a proprietary manner. Like, for instance, like a ring protection may be slightly different. They may follow a slightly different path. But it would just be, just taking the software, using it. Yeah, okay. Exactly the same thing.
And take that a step further, what about a multi-vendor environment?
In a multi-vendor environment, I'll come to that. So essentially, the management plane becomes very important, right? So what we believe that, so let me first explain the management plane and I'll come to your question. So what we do is we basically have a model-driven architecture. By that, what we mean is basically every application and everything that you see here can be modeled in a meta model. So it's basically, it follows the IMM model. IMM is basically a very old, it's basically a Backus-NOR format, which IBM pioneered long time back. And it's been in use in telecom networks for a long time. So we chose that IMM model. It's basically, what it does is it takes the managed object and basically makes a meta model out of it. So all the validations, right, static validations like VLAN 1 through 10, so anything above 11 basically is an error. Those kinds of static validations are done at that layer, basically, from that meta model. And dynamic validations are handled by the respective protocol. So dynamic validation would be like you try to configure a line card and the line card is absent. So that would be the, those kinds of validations basically are done at the protocol layer. So what happens is you have a meta model, and then from that meta model, we generate that southbound wrapper on top of the protocol modules and the northbound module, right? So that would be CLI, SNMP, or REST, or anything, any future plugin, basically. So essentially what you have here is not a stovepipe approach to management. It's basically, you are looking at it in a meta language. So essentially you can easily plug fit in to any existing infrastructure. By default, we have a Cisco-like CLI. We'll actually show you the basically how that works. We'll give you a demo, so you'll be very familiar with the interfaces. But if you want it customized, we can certainly do that because it's a meta model driven. So from a SNMP standpoint, it's a standard. So those SNMP MIBs, right? On day one, you basically get all the MIBs that you need. The only differences would be chassis proprietary MIBs, we won't support those because that will be vendor specific, right? But everything else would be the same. You won't see any difference, basically.
So it's that telemetry, that hardware-based telemetry that will be the biggest impact. So as my operations team from a practical, we're going from this platform, or we have a multi-vendor platform, understanding and even abstracting that layer of telemetry is where I might run into trouble.
You might run into trouble, but now newer standards like INT is coming in, right, in network telemetry. So what we are finding is like most chipset vendors are basically have some plans. So it's not, earlier it used to be like you have Broadcom with Broadview, and Marvell has their own statistics collection and so forth. But now, they're all converging, basically. But at any event, we can normalize any flow table that is out there and give it out as an S-flow. By default, we do S-flow, and we can support IPFix if your chipset has the capability, or we can map S-flow into IPFix, right? That's another way to get the telemetry data. So essentially, we have this model generator tool. So it doesn't stop you from, it doesn't have to be our own protocol module. So let's say you have some specific application that you want to write on this particular OS. You could write your application here and model it using the same principles, and basically use our tool and generate the CLI for that. So you get a consistent look and feel. So your application looks as though it is part of that operating system framework. Right? So that's why this is very powerful. So this is where typically people talk about CapEx, but I always think about the OpEx as well. Because that's where you have to train people on new interfaces and such. Here we don't have to break that model. Basically, whatever is your existing environment, we can actually custom tailor those CLI basically.
In that modularized approach, where there's a kind of consistency across boundaries and across different vendor solutions, makes your SDN answer a little bit better. Yes, it certainly does make it better. But even in the traditional technologies, right, like if you're used to Cisco CLI, we can give you a Cisco CLI, right? Or if it's a Brocade-like CLI, we can give you a Brocade-like CLI. So essentially, it'll work in your existing model as well as in the new domain.
So you've mentioned a couple times, if the chipset supports it,
Yep.
And what I see is a bit of a learning curve for some enterprise customers, because now they have to sort of learn how to buy network hardware like they're buying PCs, right? So
absolutely.
So is there guidance that you're providing to them about, do you have any certified platforms or certified, I guess, pieces of hardware? Do you have a program for that?
So what we have is a hardware compatibility list. So in that we will specifically call out, right, use it for edge aggregation, right, if you're using Qumran.
Because if you're trying to basically position a Tomahawk for edge aggregation, you'll be missing things like ring protection, Ethernet OAM, right?
But you're calling out specific chipsets or specific white box?
White box with the chipset, what is supported in that, right? So we have to provide both, basically.
And are you doing any kind of testing or validation of performance of those white boxes
Yes,
as well?
yes. We can certainly provide you offline like what we gather, right? So we gather raw protocol metrics as well as how many routes can be stored, what is the route insertion rate, what is the CPU utilization. So for every protocol, plus also solution, limited solution set topologies that we see across.
Yeah, because that's the largest, I think, hurdle I see for white box is if you look at the traditional vendors, right? They provide a complete solution with validation and says, here's the features, here's how fast it works. So customers like to see that kind of documentation. So
Yep. So we have pretty extensive, in-house testing that we do, and we also do interoperability testing. Basically, even though it's not by an independent organization, we have other vendors' equipment in our lab, and we test it just to make sure that everything works.
And you publish those test results?
We give it to customers whosoever buy it, because that's a area where it can be problematic for us if we are not independent, right?
Of course.
So that's at later as this market progresses, we will submit for testing with. We do testing of our protocol modules. Traditionally, we have done it with external vendors like Isocore and so forth. So those stacks are tested, but as a solution, as and when an opportunity does arise, we are, pretty happy to submit to tests.
Thank you.
Is that hardware compatibility list available publicly, or is it?
Right now, we have a limited one, but
website, and we will keep updating it.
as and when we have more platforms come in and more ODMs come in, we'll keep publishing those.
I did see that on the website when I was looking at the company. When you say there are more coming, is that a priority for the company to expand beyond the couple of? It really is kind of a small list on the website. Is that a priority to expand that?
Absolutely.
Yeah.
So we are looking. We are seeing some new ODMs come in. Traditionally, like VWin, we don't hear about them much, but in China and in Asia, they are very big. And there are some boutique ODMs like Interface Masters out here in the Valley. They make special devices like packet brokers and such. So we cover those also. So we want to be on multiple platforms. So our aim is not just the Dells of the world, but a bigger. And you start seeing Celestica and so forth. You'll see that list expand quite drastically.
Okay. And when you said in a previous slide, you mentioned standard silicon.
Yeah.
I assume that just means cheap.
COT silicon, yeah.
Right, COT silicon.
COT silicon.
Okay.
But if somebody, this software is also available as a knockdown kit. So we also give. That's another area where we are very active. What we are seeing is like some very large internal customers like who are on the service provider scale. I cannot name names, but these are very large data center operators and SaaS providers. So essentially, they have started toying around with the idea of building their own switches, basically, own OS. Right. But that's for their own consumption. So in that case, what we do is we basically license the entire source code to them. And then they add their secret sauce on top of it to make differentiated services possible.
So would you say then that thus far, kind of a primary focus has been in maybe the service provider or the very large web scale enterprise verticals?
That is where things have started out, partly because the platforms have become available there. But as you start seeing more and more white box vendors come in, I expect to see that spread across to enterprise as well as in limited cases.
So do you expect the platform to be pretty much what it is now then, or would it be a different approach to the enterprise? And
it'll be a different approach to enterprise because you have to make it far more friendly.
Okay.
Right? Because enterprise, it depends on the type of the enterprise. Some enterprises are as sophisticated as providers, right? And some are not. So in those cases, it has to be like traditionally. I came from the traditional networking world. So basically, like if you look at the Catalyst series, right, like the 2K, 3K, so that will be like the typical small, medium enterprise, basically. And the high end would be Catalyst, like Nexus, like. right? So, but we are geared for both, basically. So our user interfaces would change depending upon, and the feature sets would change, right?
Well, you say they would change, but you're still really promoting openness with NetConf, and you mentioned REST a few times, so that's pretty ubiquitous across the board.
But since that REST API is there, basically, it's very easy for us to put together a graphical interface, basically, right?
Okay.
So if you look at it, like nothing precludes us from running Node here, because, right? Once you have the Node, then you have JavaScript. There are so many visualization formats there. So Angular, if you take that, building a graphical interface is like very simple because the REST APIs are there.
Yeah. So then can I just have one follow-up question. I know I'm asking a lot now. And it was based on something that somebody asked before, but, or said before. When you say, we've been hearing from our customers, we've been hearing, right? To me, that's very ambiguous. What kind of verticals, what kind of customers, without naming names, are you hearing these requests about disaggregation of hardware, software, and all these kind of things? Because that tells me you're answering the question with your product. This is the answer to their problem. Who are these customers?
So some are basically, you'd be surprised, like these are very small enterprise customers with 4 sites, 5 sites. And this actually, we were surprised when we started seeing that traction from Australia of all places. For MPLS, basically just a plain VPLS hub and spoke arrangement, basically. And they had their provider, but they are now the provider as well as their own consumer, basically. So that's a pretty new thing developing for us, basically. And then there are small providers, basically. Small providers in the Australian outback where they're testing around with the last mile access, basically. Then it spans the gamut to edge aggregation, where I'll show you some use cases where we have been very prevalent. But most of the use cases that have started off, right, initially has been very large enterprises, partly because they are sophisticated enough to deal with this kind of challenge, right? And over time, it will bleed in, but we don't know when exactly. But for us, we are here, so we know that when the time comes in, we're ready with the product, basically.
Sure. Well, and the market dictates that, the customer demand. And my question was really is what's the problem that you would be trying to solve for an enterprise, and what are they coming to you? What are the problems that they're bringing to you?
So some of the things are basically, the common complaint I hear is basically, if they need a very specific feature, right, it's very hard to get the attention of a very large vendor, basically. Very large OEMs, typically, unless and until, those use cases repeat, there is no incentive for them to basically develop it, right? So that's one thing. Feature velocity is one thing that came in.
Feature velocity.
Yeah. And the other thing that comes up quite often is like the price per port, basically, price per bit, right? So that comes up quite often. And the fact that, there is very little learning curve involved with our product basically is another attractiveness for them, basically.
I guess the only thing I wonder there is I have to assume that you want the company to grow incredibly. So how and why would you continue to deliver that kind of service to the end customer where you say, you need a feature, we have a feature that will make it for you once you're a $100 billion company or something, I guess it's just part of the business model.
It's part of the business model, partly because it's at the end of the day, if you look at it, we just focus on the software, so things are a little bit easier for us, basically.
Okay.
Whereas a traditional vendor, right, they have to think about a small problem called inventory.
Yeah, no, that makes sense. Yeah.
So that's where the agility comes in, right?
Okay.
I got a very quick one, not to hold you up. Looking at the hardware list on the website of what's supported and everything like that, looks like there's one model on here that's a 48 port, just true copper, non-SFP. So I'm kind of looking at it, okay, I go from the data center all the way down to an access switch. Is there going to be more of a push for that access layer? That's the biggest thing I'm thinking of. Is, so if I wanted to go IP Infusion top down, would I have that access layer option?
Yes, absolutely. So 1 gigabit, we're spending quite a lot of time validating 1 gigabit with PoE. And we are also looking at edge aggregation switches like a typical PE, a very cheap PE, but with more density, like a Qumran series, for instance. So you'll see a lot of Qumran series come in.
Okay.
It's just that the vendors are, as and when we get the platform, we get started with the cycle. And then they have their own way of releasing things, right? Dell may release Qumran later than anybody else. Acton may release it much faster. So it depends.
Gotcha. Thank you.
Yep. Okay, so this is the management plane. And basically, the southbound piece, basically what happens is you essentially have these protocol modules. And on top of that, we have this management interface server and the client piece, which is basically auto-generated code. So any new protocol that comes in, our management layer basically picks up very quickly, because most of the code is actually auto-generated basically, because it's a meta model driven. So that's what gives us that flexibility to add protocols very quickly. And that even for managing the chassis, the same thing applies. We have something called as a CMMD module. So depending upon what kind of device it is, like it could be an I2C device, like a power supply, for instance. Even if it's a different power supply, we kind of normalize it, because there's a protocol daemon for it. Fan control, LED, those kinds of things. Okay, so this is what that API would look like, right? So if somebody were to, and this is another area where, for large enterprise customers, right, they want to extend and add to the capability that is already there. For instance, be able to, do time of the day routing, right? Routing's basically, traditional routing will tell you something else. And they want to do some traffic engineering piece that they want to deploy. And that is very specific to their use case. Then in that case, they can basically get hold of the, this is the hardware API, but BGP, for instance, right? You can pull everything, because we used to cater to, engineers in other companies. So these APIs are very well defined. So as new APIs are coming through, standardized APIs are coming through, we will just map it to that. So we can make it almost look like an iPhone-like model. And you would wonder how. Basically, these APIs could be exposed through containers. Basically, it's a Linux platform, and on top of that, we could give you a container. So essentially, we manage that container. And inside that container, you could write your application. And even if your application fails, we'll contain it within that container. But it gives you that flexibility to add capabilities. Let's say if you're up to it, you could basically expand on what we already provide, right? So I just wanted to briefly touch upon the APIs. So sample use cases, right? So essentially where we want to go with this is, given the platforms that we have, right? So we have Tomahawk, Trident 2, Trident 3 Plus, Qumran, and Jericho. These are the platforms that are out there today, right? And in the near term, in the next 2 to 3 quarters. So given that, we believe we can do CPE. We can basically do wireless edge aggregation, kind of like a ASR class device, right? Because the chipset has those capabilities, and we can fully exploit it. So what can we do on top of that? We can do things like MPLS, MPLS-TP, basically carrier Ethernet services. The protocol modules are all ready. Basically, we just want to exploit, as and when the hardware comes in, we want to exploit that. So it could make a very good aggregation device, because if you notice here, right, the OLT, the PON networks, they're all getting deployed at a very fast clip. So if you want a perfect box that could act like a aggregation device, right, that could bring in LTE, DSLAM, as well as CMTS in a multi-access transport environment, you could basically make the case. A Qumran-like device, you don't have to have a big refrigerator-style chassis. You could basically have a couple of these stacked together, and essentially, you get a very high density. And in the backhaul, you could do the traditional services like VPLS, carrier supporting carrier, pseudo-wire transport. So that is what we are positioning. And in the
if carriers want or need processes that run close to the hardware, do you guys work with carriers to get that code integrated into that platform, or is there a user addressable way to access the platform to write code directly to the?
There are 2 ways that we can do that. One is the container-based approach that I talked about, where we can give you that abstraction and expose that abstraction API, and you could write it. But typically, hardware we really don't want anybody touching the forwarding plane because it's finely tuned for performance. Unless and until you know what you're doing, it's probably not a good idea, basically. But it's there. Like
So not as close to exposing the. I want to access your abstraction, but I want minimum latency. So I want it to run on the same CPU as my white box.
Yep.
Do you guys? So other than the API, because the API I can that's another box outside of the
Yep.
the chassis. If I want the code to run on the chassis itself, but in the environment that you guys provide, so if that I'm accessing that same through either via API or some type of hooks, I have a container that runs on the same physical box.
Exactly. So if you notice, there was a brief mention on that. So this is that container, basically. Right? So we manage the life cycle of the container. So essentially, if something happens with your application, we can preempt it,
Okay.
basically, right? From killing the box.
So it shouldn't, in theory, the core services of the box wouldn't go away. So I still pass IP traffic as that container restarts or whatever needs to be done.
Exactly.
Okay.
So, each one of these applications are also like that. Like if this process restarts, right, we can keep the hardware plane going because there's a clean separation here, right, between the control and the data plane. So then what happens is like the ZebHA framework that that Tetsuya mentioned, basically what that does is like it keeps track of all the states, basically, and when if there is a stale route, we can selectively remove that entry, program that in the fib. So that's where the resiliency comes from. Even in a pizza box, we can provide resiliency. I want to touch upon use cases very quickly. So this seems to be pretty popular because large-scale DC design, ever since the Lakupo draft came out, this seems to be a popular application where you terminate L2 right at the TOR layer, and everything is basically completely BGP. So you use private ASS basically to create very large cluster design. So we'll see an example of that. Basically, we have configured, and here we have taken a switch from Dell, switch from Acton, so multi-environment basically, but to showcase how we can do this, right? The other is currently, we are working with London Internet Exchange. It used to be Juniper and Extreme, I believe. So Juniper's on London 1, and on the Extreme side, they are basically looking at deploying our. So if you go to links, you should be able to see their topology. But in a nutshell, if you were to abstract it all out, what it is they're replacing the Extreme switches, and they're putting in Tomahawk. So Tomahawk basically becomes the spine, and that runs through London. It has got multiple, so it's like a ring-like architecture. Think of it like a metro ring. And then there are drop-off points, basically. I've just shown 3 here. Essentially what they're doing is basically they're using VPLS, and they also use, they're deciding to go which way to go between VPLS as well as VXLAN. And it will be a BGP-based EVPN, essentially connecting between the multiple end users, basically. So it's one of the largest exchanges, and here it's built entirely using Trident 2 and Tomahawk architecture. So this is one where we are currently working on. And the other two, we are still working with these guys, so I cannot give you names, but one is in Norway and the other one is throughout Europe, basically. And pretty much, in this case, it's a VPLS use case. They're taking a TOR switch and converting that into basically a DCI using VPLS. And this is a case where we work with the hardware to make that VPLS piece happen, right? So it's fairly straightforward. You're mapping the VLAN into VPLS circuits, basically. The other use case is basically very interesting, the edge aggregation. So here, what is happening is like you basically have DSLAM, and you have this integrated layer 2 switch where they're using the switch for 10, 100 gigabit connections. So it's like a broadband backhaul. So it sits behind the DSLAM and provides all the traffic grooming. So if you were to look at, So I'm allowed to show only pieces of what they're doing. But this is something that we completed. We just completed the POC, and it's Europe-wide deployment, basically. So essentially what it is like you basically take the standard single-tagged VLAN, and then you're putting it into a carrier-based VLAN, so basically encapsulating it, double-tagged, and then you're handing it off to the communication provider. Multiple providers basically can come into your home. Basically, that's the thing here, right? And we do everything like from classification, metering, measuring, policing, the entire gamut of QoS, basically. A lot of QoS here, right? Because you're grooming traffic into the network. So this is a use case that you do with switch. So because of the versatility we have with software, right? And if the hardware permits, we can basically do, we can morph that into any network element you want it to be, essentially.
And then from a management interface perspective, we haven't talked a lot about, can we create isolated or multi-tenancy using the same methodology?
Yes, yes. So we support full VRs as well as, VRFs as well, right? So one use case Tetsuya can mention in OcNOS, even with OcNOS we can do the same thing, basically. Okay, so this is basically a large carrier, right? Edge aggregation use case. So we saw in one case it's basically a DC-based interconnect, and then in other case it's a IXC, where it's a very large-scale network. And then we have these small deployments where it's like a hub-spoke kind of deployments, basically. And as these platforms become more capable, right, we can also provide things like BGP MPLS, L2, L3 VPNs. We can also provide things like IPsec VPNs, very similar to DM VPNs, like in Cisco, like GRE, VXLAN. So all those things are basically there.
MaxSec, FIPS 142, and all that stuff?
FIPS 142, we'll have to work with the vendor because it's not just the hardware, right? It's software, hardware, plus we'll have to go through homologation cycle, basically. So we'll have to work, and same thing for EL4 too. So because there's a dizzying array of boxes, so stack-wise, we can qualify, but then that doesn't qualify for FIPS. Right? So we'll have to qualify the entire system. And in terms of interfacing with controllers, right, we basically have multiple interfaces. So coming back to your question about interfacing with controllers, right? So with the if you look at Open Daylight, right, how we can interface with Open Daylight is we support BGP LS. So you can interface with the LS module there. And we can also support OpenFlow. So it will work with OpenFlow would be another way. PC is another way. We can interface with the controller. The netconf, all of these controllers support netconf also. So essentially, you can pass the topology information from the BGP side. We can pass it on to the BGP LS. That will get updated in the topology manager within that controller. And that can be fed up to using a net plugin. Basically, you can pass it on to the cloud OS. And we typically don't, what we believe in working with ecosystems, basically, rather than developing our own controller. It doesn't make any sense because we focus on our core competency. But we'll validate it against OpenContrail or Open Daylight because these are the more common ones. And we'll also work with, since we work with Dell, we'll also work with Nicira now, so NSX. So that was a quick snapshot on what the operating system does today. But as and when this market progresses, you'll start seeing more capabilities that we have. From a full stack perspective, we do just about anything you can imagine in terms of routing and switching, because we support everything all the way from MPLS TP, MPLS to newer protocols, basically segment routing, new standards. It's just that the hardware always lags. So,
The hardware always what?
Lags, right?
Oh, okay.
Yeah. So when the platform comes in, that we don't control, right? So.
Question from Twitter from Carl Fugate about support for barefoot networks to Fino.
Tofino, we just started engaging with them, so we hope to see an integration basically soon, sometime soon, by Q4 is what we think, if everything goes well. Because we work with the Acton and we also work with vWin, and both of them are ODMs too for the Tofino chipset. So
You mentioned the hardware lags a little bit. It's kind of like your OS is 90% of the solution, we'll say. I mean, that's throwing a number out there.
Yep.
And it's once you get a switch in your hands where you can work with it, you wrap up that final 10%. Is that kind of how it works?
Exactly, that's how it works, right? There are two things, right? One is the chassis support, basically. If there are new things like, there are some new bells and whistles, like let's say from an interface standpoint, a 25 gig came in, or a new PHY came in, we'll have to account for those, because now we are the OS, right? So we'll have to develop that glue code, and then we'll have to also work with the diagnostics that is there on the new chassis, that we have to integrate. Because from an end user's perspective, they don't really care what OS is running. They want to see the diagnostics happen seamlessly, right? So those are the things that would take time. And the other piece basically is typically running solution testing, scaling, like some may have an external TCAM, for instance, right? Then we have to basically think about how efficiently to use that TCAM, basically. So those differences would be there from chassis to chassis.
So from a hardware abstraction layer, from a OS, so in theory, you mentioned this earlier, I can run this on Windows, I can run this on Linux, I can run this on basically any OS that I have drivers into, basically. And I'm pretty sure we'll get into this in the virtualization, the VNF and NFV conversation. Will this run on something as simple as a Raspberry Pi? Where's the limitations?
Absolutely. So it depends on the Raspberry Pi. You'll be limited by memory and the
Right.
CPU, right? So obviously you're not looking at full routing table there, right?
Right.
So
Carrier grade.
No, it's not carrier grade.
yeah, but if you want to,
We'll take a full feed on the
if you shave off everything, right? Shave off everything and you want to run it, yes, you absolutely can. We can get up to 60 MB, like if we shave off everything, right? So it can be a lightweight device.
That feeds actually into my next question. In your hardware compatibility list, I understand that the SoC chips are all pretty standard Trident, Tomahawk, but there's different CPUs listed there.
Yes.
Everything from x86 to Atom to quad core. Do you have guidance around performance for what CPU platform should be used? Again, going back to my previous question, because I can see where you would have performance differences in certain protocols, perhaps, depending on the CPU platform.
Yes. Some chipsets, right, like Helix 4, for instance, will have an embedded ARM core in it. So you don't need a separate control plane. But then you can only do certain things there, right? So basically, depending upon the CPU, yes, absolutely. CPU plus also memory as well as TCAM space also.
So if you look at traditional networking, and one of the things that we used to all worry about was, oh darn, is that feature process switched or is that a hardware-based feature?
Yeah.
So I guess that's what I'm trying to understand is how do customers know what things to worry about? I mean, do you expose that in some way in the operating system so that people know what's handled in hardware?
Yes, we basically call that out. In our documentation, we do call it out, right? So we basically would say like BFD on this platform is like software based, right? Because it doesn't have a BFD processor.
So is that documentation is on your website somewhere?
It's not on the website, but it is basically, partly because there is some sensitivity to it. Like I can't basically come out and say Broadcom doesn't support this, right? We have to work with every vendor. So what we do is like in this release, we support this particular, so we have a matrix basically. Inside that matrix, we'll call out, the limitations, what's supported, what's not supported. It gets detailed basically.
Well, just to add on to the performance part of that is, do you have guidance around what everything, we have an expectation of line rate.
Yep.
But certain hardware, certain chipsets, we have an expectation of a nominal marginal, less than 1% or less than 0.005%, or does that vary, or do you put on a certain level of overhead on these devices, or is it universal or varying based upon what type of chipset you apply to?
It varies also on design also, basically, right? If I were to take Trident 2, it may not provide the equivalent thing on another platform. We expect it to be close, but there will be minor differences. It depends on the I/O bottleneck, memory bandwidth.
But are those differences software or are those differences hardware?
Some are hardware, but software-wise, you would expect to see the same performance.
Exactly. Then that's why I asked to that effect. Yeah.
All things being equal, yeah, yes.
Could I ask a question about features that are available? You said that it was that it's modular, right?
Yep.
And I think when we were talking earlier about ZebOS being OEM, that a vendor could pick what features they wanted. And since OcNOS is powered by that,
Yep.
are all of the features available, or is this something that's also modular and I've maybe got to license certain stuff, or?
Yep. I did, actually, I didn't talk about it. So we basically, what we have done is we have an IP base image and we have an enterprise image. So the enterprise image has all the bells and whistles, and IP base basically just does plain L2, L3. But that L2, L3 covers everything from standard switching to Ethernet OEM, all the way right up to Trill SPB. So we keep it very simple, basically.
Okay.
So it's not more granular than that. I was looking at I was wondering the same question, at the modules and how they're broken out by MPLS. So you're not licensing that particular?
No. Well, we basically want to make that choices very simple. Basically, if the hardware is capable of running it, you have CPU and memory, we want to give you that entire list. And we don't even vary it out by 10 gigabit or 100 gigabit. We don't make those things.